So till now we have discussed the series connections of resistors. So now onwards we will discuss some points about parallel connections of resistors. Let us consider the arrangements of three resistors joined in parallel with a combination of cells. See R1, R2, R3. These three resistors are connected in parallel. So make a parallel combination of XY. So this is X, this is Y. Of these resistors having a resistance R1, R2, R3 respectively, connect it with a battery. So it is connected, all three resistors connected with a battery and a plug key, okay, and ammeter, okay, as shown figure in 12, and also connect the voltmeter in parallel. So voltmeter is connected along with the resistors, that means parallel connection. So these four are in parallel position. Okay. Plug the key. Now plug the key. Note down the ammeter reading. So let the current be I. So whatever we are supplying current, no, that is I. And also make the voltmeter reading. Voltmeter reading also you note down, that is V. It gives the potential difference. Yes, correct. This is X is one point, Y is another point. So in between there may be a voltmeter, that is this one. So no doubt there may be a potential difference, that he is telling. Okay. The potential difference across each resistor is also V. Each resistor you connect. Each resistor one voltmeter connect and you note down. So whatever you are getting volt, that is also a V. That means voltage is constant. Okay. See, V is equal to V1 plus V2 plus V3. But here voltage is constant. So from X and Y point it is equal to V, and also if you check all the three resistors with voltmeter, you will get a constant V. That means V is equal to V. Okay. Now take out the plug key, remove the ammeter and voltmeter from the circuit, insert the ammeter in series with the resistor R1. You put somewhere here one ammeter, same ammeter you put one. So note down the ammeter reading. Now full circuit we have taken, that is I. Now note down the independent resistances. So R1 you take. R1, so along with R1 you insert ammeter and note down the reading, that is I1. Now this you remove and insert with R2, that is I2. Now this you remove, insert here. So that you note down, that is I3. Okay. So voltmeter also same, like that you can connect between this resistor, and between this R3 resistor. Similarly measure the same, whatever I told you, same thing here you have shown. Just you remove this, you put here, insert here, and remove this and insert here. Note down the ammeter reading, full ammeter reading, and independent resistance ammeter reading, and voltmeter reading. Okay. It is observed that the total current I is equal to the sum of separate currents through each of the combination. So we are supplying current, na? So that I is equal to some current is going R1, that is I1. Some sort of current is going to R2, that is I2. Some sort of current is going through R3, that is I3. Okay, that is telling is equal to the sum of separate currents through each branch of the combination. That is I is equal to I1 plus I2 plus I3. So we know that Ohm's law, we know that V is equal to IR. So separate it, I is equal to V by R. So V is constant. So here I told V is constant. So V is constant. So that means this you apply to all individual resistances. Okay, that means I1 is equal to V by R1, comma I2 is equal to V by R2, comma I3 is equal to V by R3. Correct na? Now what you have to do? So this is parallel connection. Correct na? So that means V by Rp is equal to V by R1 plus V by R2 plus V by R3. Okay. Now you take volt common factor from this. So we will get V. So 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. So we cancel. That means what we got? So 1 divided by Rp is equal to 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. This is the standard formula for parallel connection. So that is telling that we may conclude that the reciprocal of the equivalent resistance of the group of resistances joined in parallel is equal to the sum of the reciprocals of the individual resistance. Reciprocal means 1 by Rp. That is telling. Okay. So this is the standard formula for parallel connections of resistances. So one example we'll see. In the circuit diagram given 12.10, suppose the resistance R1, R2, R3 have a 5 ohm, 10 ohm and 30 ohm. So this is given 5 ohm, 10 ohm and 30 ohm. So respectively, which have been connected in 12 volt battery. So battery is 12 volt. Calculate A, current through each resistor, the total current of the circuit and the total circuit resistance. So given, so before going to write the answer, you have to analyze the question. So that's why you have to mention given. What he has given, R1 is equal to 5 ohm, R2 is equal to 10 ohm and R3 is equal to 30 ohm, and voltage he has given 12 volt. So what you have to calculate? The current through each resistor, that means I1 question mark, I2 question mark, I3 question mark. Okay. The total current of the circuit, that means I also question mark. So we are supplying I, that is also question mark, and the total circuit resistance, that means, so this connection is in parallel, that means 1 by Rp you have to calculate. So this much questions you have to answer. Now one by one we will see. The current is equal to Ohm's law. So Ohm's law, V is equal to I R. Correct na? Now one by one we will calculate. This is I is equal to V by R1. This is I1, which is equal to V he has given 12 volt and R1 he has given 5 ohm. If you simplify this, you will get 2.4 amp. So it is equal to I1 is equal to 2.4 amp. One current, that means I1 we got. So current flowing in R1 resistors we got 2.4 amp. Like that, I2 also we calculate. I2 is equal to V by R2. So that means again 12 volts same divided by 10 ohm. So bottom 10 is main, 10 is there means just you put one dot here. So that means 1.2 amp. So that is equal to I2 is equal to 1.2 amp. So like this 10 denominator, if you are having 10 100 means just you think, just you putting dot is enough. You need not divide, just you put one dot. 100 means you put one dot here. Okay. So I2 also we got. Now I3 is equal to V by R3. So which is equal to again 12 volt divided by 30 ohm. So which is equal to you get 0.4 amps. That means I3 you got 0.4 amps. So from these three we can calculate I. Correct na? I is equal to I1 plus I2 plus I3. So I1 is 2.4 amp plus I2 is 1.2 amp plus I3 is 0.4 amp. So if you add these three, you will get 4 amps. That means I is equal to 4 amps. Total circuit current is 4 amps. So this one solved, this one solved, this one solved, and this also solved. Only left is 1 by Rp. So now we will calculate 1 by Rp. 1 by Rp is equal to 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. So which is equal to 1 divided by R1 means how much? 5 ohm plus 1 divided by 10 ohm plus 1 divided by 30 ohm. So here I will take 1 by 5 ohm as a common factor. So here what you will get? 1 plus 1 divided by 2 plus 1 divided by 6. Okay, now we simplify this. 1 divided by 5 ohm is equal to, you take LCM 6. So 6 plus 3 plus 1, which is equal to 10 by 6. Okay. So what we got? 1 by Rp is equal to 1 divided by 5 ohm into 10 by 6. So if you simplify this, you will get 1 divided by Rp is equal to 1 divided by 3. So you reciprocal this. So you take Rp numerator. So left side if you are taking Rp numerator, right side also you have to take top numerator. So Rp is equal to 3. So total resistance, circuit resistance is 3 ohm.